school at the state ski meet, we had to stay at the lodge at Giants Ridge. So I went into the, asked the hotel clerk, what room am I in? And you know what the clerk said? The lobby. Thank you. Might get my collection. Okay. Tomorrow's quiz. About each one of those tomorrow. So you got to know how to find the derivative of parametric equations, find the magnitude of a vector, find a unit vector, find the velocity of a vector, find the length of a curve, and solve initial value problem with a vector. Any of those, send a panic button and you want an example of. All of them. All right, Christine. First one. All right. So that one is something like this. X equals t squared plus 2.
Is there homework next month?
No.
Oh, okay.
Y is 3t.
That makes sense. There's like space.
You're asked to find the derivative with respect to x of those two parametric equations. So what you do is you find the derivative of y with respect to t. You find the derivative of x with respect to t. So dy dt would be very simply 12t to the third plus 2t, and the derivative of x with respect to t would be 2t. What?
T cubed?
That's it?
Or 12?
Where?
12 T cubed now, sorry. I'm sorry, from the angle I'm in.
Okay.
Sorry.
Okay,
I'm
that's all right. And so now this is,
Sorry, go ahead.
oh, you could reduce this if you wanted, and you could say this is 12t squared plus 2 over 2, which could be reduced to 6t squared plus 1. Just keep it simple, okay?
I was going to ask if we have to find a second.
Yeah, that's what I'm going to do now.
Okay.
Yeah. So now, this is considered y prime. So now the second derivative means that we must take the derivative of y prime with respect to t divided by the derivative of x with respect to t. So in this case, we take the derivative of y prime, which normally would have been this had it not reduced. Then you had a big mess, but you had to use the quotient rule probably on that. We don't have to use the quotient rule because it's simplified in the example later. Okay. So the derivative of this is simply 12t And the derivative of dx dt is back here 2t.
So are we not doing anything with cycloids then? For this quiz?
No.
Okay.
The quizzes are always very basic. Just, the basic ones. Okay, anything else over there you want to refresh on?
Except for the one I failed.
Or is that okay on that, Christina?
Yeah.
Okay. Susan?
So she already asked about cycloids, so will we have to do like surface area of anything?
No.
Okay.
Yes.
When you say magnitude of vector, like, will we know the A and B, so it's just
Yeah.
square root of A squared
Yeah,
plus B
so-
squared?
So to find the magnitude, you'll be told vector b equals 3 plus t I plus 2t minus 1j. What is the magnitude at t equals 2? Would be an example. So basically the vector at 2 would be 5i. The vector 4 minus 1, 3j. Okay? I plugged the 2 in for t. And I got, now that's the vector. What is the magnitude? The magnitude is what?
Square root of 5 squared.
Square root of the components squared. So we're looking at 5 squared plus 3 squared, which would be the square root of 34. So that's its magnitude. If it happened to be a velocity vector, that would be its speed. Now, we can kill the other one with this. What is the unit vector?
I did 5 square root of 2.
Because what we have here is we have a vector v that has a component going 5 and going 3. And the unit vector is the vector that's only 1 unit long. And if this happens to be the square root of 34, to reduce this down to 1, we have to divide it by the square root of 34. So we divide each of the components by the square root of 34. So the unit vector for this one here, unit vector, would be 5 divided by the square root of 34i plus 3 divided by the square root of 34j.
And we don't have to like reduce that or anything, we can just do it like that.
I prefer you leaving it like that because it's a ratio. If you reduced it, and got rid of the square root and wrote it like that, now it no longer tells me what the original x component was and what the magnitude is. See, this tells you what the x component is and what the magnitude is. This does not, even though it's the same answer. Susan?
Do you want us to write it with like the I and J, or can we write it in like component?
You can write a component form also.
It doesn't matter?
No,
Okay.
absolutely not. You want to write a component form? That's fine. Okay, any others?
Initial.
That's from the curve, all right. Why don't we use it while we... R is... I'll just use the same values for this. Or T. All right, this creates some kind of curve, and it starts here, and it ends there, and the time it takes to go from there to there, let's say time is from 0 to 4 seconds or whatever. What distance did that curve cover? Well, what we do is we take each little piece and add them up, so the distance, or length, is going to be an integral. The integral is going to go from, in this case, 0 to 4. And each component is a distance, and this is a distance dx compared to t. This is a distance dy compared to t. And so now we use
Alarm,
now we use the Pythagorean theorem. And so this length here is the square root of this side squared plus that side squared. So this would be dx dt squared plus dy dt squared. Alright? So, in this example, 0 to 4, dx dt, this is your x. Dx dt here would simply be a 1, there's no t's left over. And dy dt would be a 2. And so essentially you're integrating, for this example that I gave, the square root of 5.
When did we talk about that?
I don't know. Is it parametric equations? Probably 7-2, second day lecture maybe? Length of the curve? I can't remember which day it was.
Oh, I see, yeah, hold a second, okay.
Susan,
Initial value problem?
we might as well do them all, right?
Yeah.
Of course. Where did we skip? Oh, velocity vector.
What?
If this was the position vector, what's its velocity? The derivative. The derivative is its position. And so then it would be 1i plus 2j.
You did. And it's not really bad.
Huh?
And that's just the other problem on the test.
Wait, where did you get those numbers from?
Which numbers?
The 1i and 2j.
The derivative.
Oh.
Because
Okay, never mind.
the RDT, so then this is r, so the derivative of that would be 1.
Yeah.
Alright, derivative of that would be 2.
Okay. And that's the velocity then? Or the velocity vector?
That would be the velocity vector.
Got it.
So now, working in the reverse, let's say dr dt was t squared plus 4i plus 2t minus 1j. And r is 3 when t equals 0. Okay. Or 3i. Let's just do that. Okay. Solve for r. Why is it an initial value problem? Because it's a differential equation that has an initial value. So, what do you do to solve for r? Separate the variables and integrate. So you go dr equals t squared plus 4i plus 2t minus 1j dt. So now we integrate it. Of course, this gives us r. What would this be?
1/3.
T cubed over 3 plus 4t I plus t squared minus tj plus a constant. And I don't know, I just made it up. This might not work very well. Let's see here.
No, you plug in 3i for r and then...
Okay, so now, yeah, this will work, I think. So now what we do is we plug a 0 in for t, and r has to be 3i. So we put a 0 in for t. Everything here is 0. Everything is 0 here. And it has to be 3i. So that tells you that c is 3i. So then the equation would be this one here plus c, and so you put a 3i there. And so then technically what you would do is you put it inside, and you'd say vector r is t cubed over 3 plus 4t plus 3, all times I, plus the j vector, t squared minus t j.
So you put the C in with the, like the X?
Well, in this particular case, because I defined it that way,
Okay.
you know,
yeah, yes.
had r been 3I plus 7tj when t is 0, well that's not good. Well, plus 7j, then you'd be putting a 7 in for the j portion of it. Okay? So tomorrow's quiz is pretty straightforward. I mean, if you know the basic skills, you should be alright. Okay, let's finish up 10.5 lecture.
Is it test?